Perfect. So we will get started. So I want to thank everyone for joining us on this wonderful Friday afternoon in December. My name is Amal Raswadkar, and I'm the president of our local Institute of Industrial Engineers chapter. We have, when we polled our audience, about 200 active members, we heard a lot of feedback on data analytics and really looking at IoT data. And that's why we phoned our friends at Sandalwood, and they were able to connect us to a real expert. So Tim Tim Stewart is the president of Visual Decisions and has over 30 years of experience in process reengineering utilizing data and digitalization. He has worked with many large clients such as J&J, Diageo, Cummins, Wyatt, L3, and just to name a few. So with that aside, I'll turn it over to Tim and let him kind of run things. Just for timing wise, what we're going to do is we're going to give Tim, about 45 or so minutes to run through a presentation, then we'll open it up for Q&A. So feel free to add things in the chat and I'll moderate, and run things. So thank you, everyone. And with that, Tim, go ahead and take over.
All right, thank you. As Amol said, my name is Tim Stewart. I'm president at Visual Decisions. I'm here today with Sandalwood Engineering and Ergonomics to talk about getting the most from your implementation of smart factory systems with a focus on IoT or Industrial Internet of Things. So there's a growing recognition of the value of the data from smart factory systems. The focus of most of these projects is really on improving the machine performance and manufacturing quality. But there are a lot of additional uses for the data across all the different departments of an operation. And rather than focusing on the use cases that everyone starts with, we're going to focus on some of these other ones today. So the list that's presented here is meant to be more illustrative than comprehensive. There are many, many more use cases for this data within each department that are not covered here. But the list is a good way to start thinking outside the box for how data from the shop floor can be used across different departments. And as I'm going through this at any point, Amal, I'm not looking at the Teams window since I'm presenting. So if there are any questions that come up, and people feel free to ask questions at any time. I'll handle those questions. If Amal, you can let me know that they exist. All right, let's start with the operators. The data from these different systems can be used to augment operator capabilities in many different ways. Let's look at a few of them. One benefit that can be provided to operators is real-time feedback on the process performance. This can be achieved through digitizing visual controls on the shop floor using information coming directly from the machines, sensors, or even other equipment. And this feedback allows the operator to adjust the process to improve performance or quality and helps them meet their targets on an hourly, daily basis. Digitizing work instructions enables less experienced operators to support single piece flow and unique builds in sequence. And in addition to the instructions for the operation itself, these systems can reduce non-value-add paperwork by automatically capturing process inputs. And they can also provide real-time feedback to deviations from the different standards. In addition to providing basic performance monitoring solutions, these can be augmented in such a way as to help the operators perform better. For instance, at one customer, we use the detailed information across different shifts to show each operator where performance was strong relative to their peers and which areas existed where they needed to improve a little bit. And so it was kind of like a DNA for the different operators and how they ran the process. And then from a setup and changeover support, you can look at this as, before the SMET event and during the SMET event, you can utilize IoT systems to capture what are the discrete events that are happening? What is the timing of those different events? You can look as to internal or external. And then after the SMET event, you can utilize these systems to trace the performance according to the new setup design and whether they're being performed correctly or if there's still work to be done to set those new disciplines. From a maintenance perspective, these are really some of the most traditional use cases for IoT systems. And for example, many of the smart factory solutions are targeted at the predictive maintenance capabilities. So in this section, we'll highlight some additional areas of opportunity. As much as you want to utilize predictive maintenance and condition-based maintenance and optimize your preventive maintenance and so forth to increase your mean time between failures are still going to happen. So how do you reduce your mean time to repair as well? And part of that could be automating that ticket creation process. So by providing information or integration between the smart factory system and customer maintenance management system, it's possible to automate the creation of those work orders when the machine downtime occurs. And in addition to just automatically creating a ticket for the machine, if you have some intelligence at the machine itself, you can do some triage, some level of diagnosis of what the type of failure is, whether that's pulling information from the operator or looking at the fault codes of the machine or what the condition of the machine was before the failure and so forth. And you can pass that information along to the maintenance management system so that it has that context of some idea of what the problem was, so that you can get the right person assigned to the job with the right tools and the right spares to minimize that time to repair. In addition, from a preventive maintenance perspective, very few companies have a regular process for evaluating their PM tasks for their impact and whether they should be continued to be performed at the same frequency. And so the information coming from your IoT systems can help determine the efficacy of those programs, whether they should be increased in frequency, decreased in frequency, abandoned altogether, and you can actually optimize that over time to minimize the cost while maximizing the uptime. Condition-based maintenance is a little bit easier to achieve than predictive maintenance. So it can be less expensive to set up and faster to get up and running, and allows you to maintain visibility of those different process variables for the machine, whether it be temperature or vibration, et cetera, and see that the machine is operating within its normal parameters. And if it goes outside of that, then you can stop production and look to see what's happening. And then smart tools and tooling optimization, along with Sandalwood, we've worked with customers to optimize tooling usage based on the detailed information coming from the IoT systems. We worked with a customer in Michigan and a tier 1 manufacturer to look at grinding wheels, and actually looked at doing predictive quality on those grinding wheels so that we could see when the grinding wheels were worn to the point where they were going to start producing bad parts, and change the frequency with which the grinding wheels were replaced based on that prediction. And we were able to generate hundreds of thousands of dollars in savings per year by going through that process with them. The broader facilities team can also make use of these smart factory systems and data. I'll be cheating a little bit in this section and looking at how the same systems can monitor non-production equipment in the factory to get value. Energy and utility consumption monitoring and optimization can be a quick area of payback for any IoT implementation. Just by putting some cheap sensors at each machine to monitor energy consumption, it's possible to identify waste when the process is not operating. And that's just on top of the benefits of having that information for predictive capabilities at the machine itself, and allows you to monitor, for all of the power consumption in the plant, what are the operations that are pulling the most power, and how can you start to optimize the energy consumption within those different operations. HVAC monitoring, all the techniques being used to monitor IoT devices can be used to monitor the HVAC equipment itself. And that can be another area of quick payback that, if you have an unlimited license within your facility, why not monitor the HVAC equipment and do the same kind of maintenance on that as you do on the actual production machines. Cold chain certification for industries where that certification is required. Those sensors and systems can be used to always track the locations and environmental conditions of materials. And the systems can then be configured to produce certification for all the different materials that require it. Fork truck optimization in large facilities, fork trucks or other material movers. Availability itself can be a production constraint, and where you leave those different things during off shifts and how you store them and where you place them, as well as the route optimization itself, can be very beneficial for different plants. And the cold chain certification, I worked with a frozen food company that had to certify that the food maintained its temperature at all times. And they were able to put a system in place, track the material movement through the plant, and basically certify that the entire time that food was in the plant, that it was at or below the desired temperature at all times. Material management, along the same lines as the above, material management can make great use of the data from the IoT systems. Because the systems have visibility to real-time production status and also the upcoming schedule, it's possible to enable several improvements to the material management within the plant. Whether manufacturers utilizing Kanban techniques or more traditional material management methods, digital visibility of the materials usage and the upcoming requirements can help to optimize the flow of materials out to production, especially in places where you have a lot of variability. Lot tracing, many companies lack visibility of which supplier lots are being used for production at any given time. And with some changes to other procedures in combination with the availability at the point of use, this information can be tracked in much more detail. Additional uses for the information will come in a later section. Early changeover notification in operations where there's a need for kitting of setup or changeover materials. Getting early notification to everyone is required for minimizing downtime. And these systems specialize in not only tracking when that upcoming change will be required, but also being able to notify a flexible list of people based on the different unique requirements of the process and all the from-to combinations and so forth. So in addition to collecting information about the manufacturing process for good parts, the smart factory system should be implemented to cover rework and other non-conforming material processes. So if you have machines where you're doing rework offline and so forth, make sure that you monitor those machines as well, because that allows you to really track information about the rework that's being done and the orders that are going through there and everything else. In terms of a customer story on this one, I had a customer that was pretty lean. They did a lot of water spider. They had water spider, what they called water spider, that essentially went around the plant looking at what needed restocking for pick bins and things like that. And they were constantly, doing that material movement. But being able to give that person essentially a tablet with a list of things that were getting low at each station allowed them to really optimize that position's efficiency. The quality department has so many different uses for the detailed production information. I can use the systems to track test results and other quality information directly, but in the end, all data that's collected from the shop floor is information that can be used to analyze contributing factors to poor quality. Whether it's environmental information, detailed tag data coming from the machines, this information can be correlated to the test information to identify potential causal factors and leading indicators. And I can't emphasize this enough, that if you have an IoT system on the shop floor that you're doing machine monitoring with, and your quality department isn't looking at that data, then they are missing out. All of that information is quality data in the end. SPC automation, for a lot of companies, SPC is a manual process that requires manual math from the operators. And companies that have dedicated systems for SPC, but a lot of the systems are data islands, isolated from other systems, and still sometimes require the manual input. And smart factory systems can not only automate that SPC process itself, but blend that information with other data from the shop floor to drive much deeper levels of analysis. And there are a lot of potential uses for the combinations of that data. Producing documentation or certificates of compliance. For many companies, they require a certificate of compliance in different industries for orders that are being shipped out to either certain customers or everyone. And smart factory systems have the ability to support gathering all the required data from the process, from test and so forth, and integrate that with other systems and then output that required documentation in the required formats. And then there are so many tools in the Lean Six Sigma toolkit that require extensive data for analysis, and IoT systems can provide pretty much all of that required data. And if they're not currently providing it, they can be reconfigured to augment or automate much of the analysis. And customer story here, I'm working with an aerospace company that needs to have documentation for pretty much everything that happens within the facility when they ship out parts, and they have to maintain the full traceability, all the way back to the suppliers, and have information about all of the testing and inspection results and so forth. And what they've done is they've created a digital birth certificate for the product, and they can actually show any customer that the OEM that they're shipping their part to. They can show not only the information about the testing and where the lots came from and so forth, but they can actually show what was the temperature, within that process as that material was going through production and so forth. And they can provide information beyond what's actually required, which is actually helping them win additional business because of that capability beyond what their competitors have. The process engineering team and manufacturing engineering also have a lot of different ways that they can use the information from these systems. Obviously, naturally, they would be involved directly in the machine monitoring and uptime improvement efforts and so forth that are the primary focus of these implementations. But there's other ideas for how they can use that data. For example, if you've ever done a process FMEA, it's a very valuable activity within the plant, but I guarantee they're not performed very often in your facility because of how long and how involved it is to perform one. However, the data collection that's being done with these systems can be used to really help automate or at least augment those FMEA processes. If you think about it, if you're looking for different root causes of failure and what's happening over time, you're definitely tracking that with the IoT system. You're tracking the probability of that failure mode occurring. You're tracking the severity of how much downtime it's causing. And if you look at your probability of detection, that can actually help guide you in terms of how you're setting the monitoring up in the first place for what are the things that I should be doing, that I should be monitoring in order to maximize my probability of detection. From a bottleneck identification and line balancing, depending on the structure of the manufacturing operation, job shop, linear flow, et cetera, the data can be used to identify what is the actual bottleneck in the process, not just from a mean time of operation, but incorporating all the variance and everything else to achieve better flow through the entire process. You can use this information to help author work instructions, not just how the process is supposed to be run, but how it actually runs. Factor analysis is the identification of different factors that contribute to the manufacturing performance, whether it's environmental, supplier material related, machine setting, who's running the system, time of day, humidity, etc. And having these IoT systems in place allows those correlations to be performed um, on the historical data instead of having to run tedious and potentially expensive design of experiments to determine the level of individual factor contribution. And with the bottlenecks, I had a customer that runs a manufacturing job shop. I mean, they just take orders from customers to build whatever the order comes in for. And so for them, identifying a bottleneck is very difficult within their plant because they have a different mix literally all the time. They never have the same mix within the plant. And so being able to monitor these systems, they were able to identify real-time bottlenecks and make sure that whatever is the bottleneck that day, that hour, they had the appropriate resources there to maximize the throughput on that particular operation. May not be the first thing you think of, but HR and EH&S can actually utilize this information as well. And the data coming from these systems can be very useful within those teams. So in some extreme cases, we've worked with customers that manufacture very volatile substances where operating conditions are absolutely critical to worker safety. I had one customer where one of their buildings actually basically blew up because they were working with a material that required a vacuum in order to process the material without exposure to oxygen. And they had a leak, they didn't detect it. They put the material in there and it went boom. So your environments probably aren't that extreme, but there are probably conditions that you can monitor for making sure that you're operating in safe conditions, whether it's just making sure that you have that lockout happening and so forth before you're processing parts. But you can monitor all of those different conditions and make sure that all the conditions that you want for safe operating conditions are there at all times. Workforce training, a strong feedback system is crucial to the initial workforce training as well as continued improvement over time. The data from these systems can be used to provide feedback that identify where reinforcement of the initial training might be required. And again, we had a customer that we worked with that was really leading edge with this, where as new employees worked the equipment, at the end of the shift, there would be a review with them looking at how they ran that machine versus how the best in class people operated that machine. And they would get continuous feedback on how they could run it better, and not done in a bad way, but done in a positive way to help them get up to speed as quickly as possible. You can track certifications for the operator. So if you know who's working at a given station, you can make sure that if there are certifications that are required, that they actually have those, and by integrating with a different system and so forth. You can also monitor for standard work compliance. There are many systems available now that help collect not only detailed information from the machines, but could utilize video and other inputs to monitor the manual activities being performed by the workers. And these actions can be compared to the standard work, and exceptions can be immediately flagged and alerted. And this actually helps to prevent safety issues where workers are not following the safe working practices and so forth. And the Sandalwood ergonomics team, combined with their systems integration and so forth, is actually a great resource to utilize here to make sure that your workers are working in a safe fashion. The operational excellence team can benefit more greatly from these systems than pretty much any other group. Nearly every single activity this group performs can be enhanced through the data coming from the shop floor. So if you're doing problem solving and root cause analysis, this is probably the most critical area where data can be used more extensively than it is in most implementations today. Even if you're utilizing something like a 5Y, it is so beneficial to be able to look at the data for each of the different answers to why, and say how much of a factor is this actually in that issue occurring. And so there's a lot of different ways to do root cause analysis. There's a lot of different ways to do problem solving, but all of them benefit from having additional data about what's going on in the process. As with Six Sigma above, most lean manufacturing activities are ultimately built on data, whether it's value stream mapping or the FMEAs we talked about earlier, or pretty much anything else. They all benefit from the different data that is provided here. Event prioritization. So if you've got a whole funnel of different Kanban or Kaizen projects that you could be working on, which ones should you be doing first? How do you prioritize those? You can actually look at the data now to tell you which of those should be prioritized because you know which ones are having the biggest effect. And the last one, fighting performance entropy, might take a little bit of introduction here, but in conversations with many lean leaders over time, and I've been a lean consultant myself, sustaining the gains is that often the single biggest challenge with these different projects and so forth. And there's a very real performance entropy that takes place. You have a team, they do a Kaizen, they figure out how to fix problems and so forth. They show how much better the process is going to be able to perform. Everybody celebrates, that team moves on, they start working on a different problem in a different area. And if you look at the performance where they just were, over time, that kind of degrades. I worked with the head of all continuous improvement for UTC with Carrier and Hamilton Sunstrand and lots of other companies underneath them. And he said that they've been doing lean long enough and have done so many different improvement events that if they'd just been able to maintain all the gains that they claimed from those individual events, they could just drive the truck past the plant and all the material would spontaneously assemble and fly into the back of the truck as it drove past. And so being able to not only achieve those gains when you do those projects, but actually maintain those gains by monitoring that performance and seeing if you have any degradation in that level of performance and being able to address that immediately so that you can sustain that new level is absolutely critical to your operational excellence success. In addition to all the different functional groups, management also benefits from the data coming from the shop floor. Many of the regular reports looked at by plant managers can either be automated or greatly enhanced utilizing the data coming from these smart factory systems. Real-time cost variance. Variance reports are one of the staple tools of plant managers across manufacturing, standards versus actuals. And with the data being collected and processed in near real time from the shop floor, it's possible to automate those reports to show profitability status throughout the day. Being able to do Gemba walks, nothing should ever replace actually performing Gemba walks out on the shop floor to see things with your own eyes, but being able to get real-time reporting as you make the walk can make it much more productive. So you can talk to people about what's actually happening instead of just going there and saying, so how are things going today? A digital status board can also give a plant manager visibility of what's happening at all times. Single source of the truth. One of the frequent complaints that I get from plant managers we've worked with over time has been that each team will show up to staff meetings with their own set of data, and half the meeting will be an argument over which one is actually true. Collecting comprehensive data from the shop floor through these systems can end those arguments by providing that single source of the truth. Data tracking and reporting waste elimination. So how many hours does your staff spend doing manual data collection, manipulating information in Excel, generating reports? If you have SQDC boards or TPM towers or any of those things, how much time do people spend not only collecting the data, but posting it up there, taking it down, editing it, typing it into Excel, generating reports from it, or printing the reports from Excel, putting them up there, and all of those different things. So all of that can be uh, eliminated and facilitated. And one of the plant managers that I talked to, um, he really wanted to simplify things, and he said, I just want to know if I am winning or losing right now. Can you tell me right now, today, if I'm winning or losing this day? And if I'm losing, what can I do to start winning? And that was a great approach to thinking things through in terms of how to collect and organize this information. Um, the finance operation and the durations not matching realities, briefly mentioned above in the context of the planning department or other contexts. I think planning is next. But that information is much more critical to finance. So if you think about overhead allocations and standard costing, more accurate data from the shop floor can be utilized by the finance group to improve their cost estimates and overhead allocations. By gaining visibility to the actual resource consumption in the process of manufacturing each product or order, the finance team can be much more granular in their analysis. Uh, the potential payback from different projects is often very fuzzy when the operations team makes requests for funds to purchase new equipment, run improvement events, or other projects. And by implementing a process of utilizing the detailed data from the shop floor to illustrate the operational impact of the suggested projects, finance can much more accurately evaluate whether to approve funding for those different efforts. And then on a more annual basis and so forth, the same applies to the budgeting process. With much more detailed visibility on the value provided by different resources and expenditures, finance can make much better judgments on whether those items should be approved for the next budget as well. And going through this information with one CFO, he actually pointed out that back in the 90s, we all looked at activity-based costing and how ideal it would be if we could actually look at each activity, how long each activity took, and add that up to the costing for the organization. But the data just wasn't there at the time. And with the information that we can now collect with these IoT systems from the shop floor, we can actually do basically activity-based costing, but for real. And I thought that was a fun quote, but for real. And he was very excited about it. The planning department can also benefit greatly from the shop floor data. There's a few different ways to take advantage of the information to create more accurate, timely, and feasible production plans and schedules that then operations can actually execute. The current status of things on the shop floor, when you're generating a detailed schedule for the next shift or next few shifts or days of production, one of the most important factors is accuracy of the starting conditions in the plant. Which machines are currently running which parts, what percentage of production lots are complete at the current operation, which resources are currently available or currently down, and more all come into play when trying to generate an optimal schedule. And being able to see that information and feed that into the planning system helps generate that much more accurate, detailed schedule. Speaking of accuracy, accurate operation durations have a big impact on whether or not that schedule is feasible. So generating a plan without accurate durations for the operation times is like trying to navigate with an inaccurate map. In addition to all the other information being collected by these systems, they have a very precise picture of how long operations actually take, as opposed to what is stored in the ERP system that's typically more for costing purposes than it is for actual planning. Accurate setup matrices, planning around setups and changeovers is often an exercise and a bit of guesswork. Many companies only know how long an average setup takes as opposed to how long it takes to go from product A to product B, how long it takes to go from product A to product C, or product A to product D, and all the different combinations there. So having all of those details captured over time and available within the IoT system makes those setup from and to much, much more accurate. And then when it comes to scheduling and once a plan gets published to the floor, it's often unchangeable until the next day or even longer. The shop floor data can not only show the current status of the plant, but can also compare that to where it should be based on the schedule. And if the gap is large enough, this can be used to kick off an update to the plan, or at least to better reflect the current reality, and also just for performance monitoring and so forth. We actually had a customer that had been scheduling weekly, kind of at best, because they just didn't have the information flow. They didn't have a good picture of what was on the shop floor at a given time. They didn't have accurate times in terms of how long things took to produce. And so there was no point really in scheduling on a frequent basis because the schedules weren't that accurate to have that level of discrete measurement to them. And by putting these systems in place, by having that accurate data, by having the starting conditions and so forth, they were actually able to reschedule twice a day and have that reflect the reality of what was happening on the floor with uptimes and downtimes and where everything was and what took longer than expected and quality issues and who showed up for work today and so forth. And being able to reschedule twice a day actually helped them produce a heck of a lot more parts because they were able to improve their material coordination and everything else. And finally, this not only helps within the plants, but also can help across the different plants. So our final group is the corporate operations team. And this is everyone in that structure from the COO on down. And so it covers a lot of ground. And there's a whole lot of potential use cases there. But if nothing else, having the same basic visibility that we talked about for the plant managers would be a huge boon for many corporate leaders. But in addition to just those things, you can start to look at best practices and benchmarking and sharing across the different plants. So as these systems are implemented, it's important to configure them to capture those work practices. This enables the corporation as a whole to be able to compare the practices across the different plants, identify what works best in different environments, and share those learnings across the company. Also, while the detailed process data is being collected at the plant, it should absolutely be shared across the organization. And then when implementing something like predictive maintenance capabilities, more data is generally better data. And so wherever there are similarities across the organization, equipment, materials, and so forth, teams at corporate and in the plants should be able to leverage the information from the whole company when looking at individual problems. Also, if you have a particular, type of failure on a piece of equipment within one plant and your maintenance team does something and it doesn't work, it, fails again the next week or whatever, that information is valuable not only within that plant, but across the entire organization so that they know that, hey, when this happens, we don't want to do that. Or conversely, if they do something that fixes it permanently and that doesn't happen again, then great. Let's share that learning everywhere and have that information be easily available across the entire organization. Every organization uses some kind of KPI scorecard for weekly or monthly reporting and management, and operations executives will often have a regular cadence call with the plants to review those KPI and what's being done to fix any misses. And I had one COO that had a weekly cadence call where they were doing everything in Excel. So each plant manager had 3 or 4 people that were assigned each week to put in, 40 different KPIs and if there were misses, what was being done about the misses and so forth. And then, those few people across, 12 different plants. You start to look at a lot of different people that are doing this reporting. And by turning this into basically a digital management operating system for the company, where this information was collected directly from the process and aggregated up, you were able to, eliminate that waste of having that many people involved across the organization that were basically just doing data entry into Excel. And this was also tied into their system where they were managing their Kaizens and so forth. And so they were able to pull that information directly as well for what they were doing about those different misses and so forth. And so the whole process led to an enormous boost in efficiency in the utilization of different resources across the company, which helped obviously the performance as well. So as can be seen from all the different sections above, there are a ton of different use cases for the production data, and the systems can be used beyond the kind of traditionally narrow use cases. Whether you're just starting down the path to smart manufacturing or whether you have a mature implementation already in place, there's likely many, many additional ways your company can take advantage of the information you're collecting from the shop floor. So if you have questions or would like to talk about how to apply these concepts within your company, please reach out to me or Sandalwood or anyone involved here. And you can give us a call, send us an email, set up a meeting at that link and so forth if you want to talk. Any questions?
So, Tim, it sounds, first off, thank you for everything you shared.
Yep.
Excuse me. It was incredible all the content you shared. Rob Simmons has a question about what observations and developments do you see on siloed systems? For example, QMSs or MESs that don't talk to each other.
Yeah, so there's a number of different efforts underway. I work with the guys at SESME, which is the official Smart Manufacturing Institute for the US. And they're putting together overall data structure that they're kind of pushing to the different software vendors out there that help to share information across these different systems. But even without that infrastructure in place, it's possible to set up data stores where you're taking information, putting it into kind of a unified namespace and so forth, and doing reporting against that so that you can link this information together and then do reporting against kind of the entire data set of what you have out there.
That's excellent. Can you, that Sesame piece, would you mind later on, when we send out the video link, sharing some kind of a link to that data structures?
Absolutely.
That'd be awesome.
Yep.
Ashley has a question. Question is, any suggestions to help management understand why to take a deeper dive into automating data on one platform? Right now there's teams of different Excel sheets and multiple leaders arguing over the numbers. Any other recommendations you have?
Yeah, so speaking of the Sesame guys, they have a smart manufacturing roadmap that they do that's actually pretty approachable. It's a pretty light lift for a small organization. It's as cheap as 10K. And what it does is it gives you that overview of what is the current state of the business, what is the desired future state of the business, what are some of the opportunities that you have to get from here to there, and finally, what's most compelling to management, what is that actually worth? And so by putting that in place and performing that activity, that actually helps you get that information to management of, hey, in order to stay competitive, the current state of the business might not get us to where we want to be. And here are some tools that you could look at that would be worth a lot to the company and really help to bridge that conversation. That's one way to go about it. But In general, those are the things that you need to do is to be able to highlight those different gaps. And that's one great way to do it.
Well, that makes a lot of sense. Thank you.
Yep.
Um, I have one question. You know, I personally have experienced a lot of these types of projects, and one area that I personally struggle with is controlling scope creep. So how do you manage that? Because I want everything that you showed and more,
Yep.
and my clients want their own version of everything that they showed and more.
So again, having that roadmap in place initially helps with that, so that you can understand, where are the biggest paybacks and how should you prioritize all of those things that I showed. Once you put the data in there, you have that data available, but then it's process change really to be able to get people to understand where that data is available, integrate it with other systems so that you have that combination of data and so forth that's available to do all those different things. And what I urge people to do is look at it from a sprint point of view and determine what are the different sprints that you want to do to look at those different use cases. Try to assign at least a rough value to those different sprints and then prioritize them. And then just be rigorous about knocking those sprints off one at a time or two at a time if you have the resources to do so.
That totally makes sense. Thank you.
Yep.
So there's no other questions in the chat, but if anyone else has any questions, feel free to ask. Looks like Tim, we can give people back 12 minutes and
That's
thank
right.
you again. This is very, very useful and it's a very timely because people are starting to think about 2025 right around the corner and thinking about, hey, what can we do? Where should we prioritize some of our efforts? So this is very, very helpful. So thank you.
You bet. And Merry Christmas, Happy Holidays to everybody.
Thank you again.
Yep.
Alrighty, bye-bye.
Bye.